So hi everyone, welcome to the next talk in our Engineering Digital Twins community. Before we start into today's talk, let me do some advertisement on publication targets that might be interesting for you if you're interested in digital twins. First of all, the annual simulation conference has its own digital twins track again this year. Submission deadline is beginning of January. So if you have if you're still looking for something to do over the Christmas holidays, this might be a good fit. If you need some more time, there is also the Twin Arch workshop is collaborating this year with the Digital Twin Engineering's workshop and is co-located with IXA. So deadline here is February 18. So if you still need some more time to publish your work, that might be a good fit. But with that being said, let's switch to what we're doing today, to the Engineering Digital Twins seminar series talk, where today we will hear a talk by Judith Michael. And then this is our Christmas talk, so the last talk for this year. And then next year we will start on January 15, where we still have to fix the presenter, but we already know that end of January, so 2 weeks after that, there will be Thomas Bedner from the Vienna University of Technology talking to us. But with that being said, let's switch to what we're all interested or excited for today. Judith Michael talking to us about sustainable systems and how digital twins can help us here. Judith is currently a postdoc at the RWTH Aachen and also team lead there. And she's doing research on software language engineering, model-driven software engineering, and especially engineering digital twins, where today she will show us how these digital twins can help us pave the way for sustainable systems. So let me stop sharing, and Judith, the floor is yours.
Thank you very much for the nice introduction. We can check screen, correct. Yes, great. So thanks for the invitation. It's a pleasure to be here and to talk with you about the research that fascinates me. Maybe just some aspects about myself. Daniel has already told you a little bit about myself. I did my PhD in 2014 in Austria, so I'm Austrian, in the group of Heinrich C. Meyer on cognitive modeling for ambient assistance. And since 2018, I'm working with Bernhard Rumpe at the Chair for Software Engineering, where I'm leading 8 PhD candidates in our group. And I'm especially working in several projects. The main one is where I'm the deputy coordinator of the work stream Conceptual Foundations on Digital Shadows within the German Cluster of Excellence Internet of Production. So we have quite strong connections to the colleagues from mechanical engineering and also within the Center for Systems Engineering. We're working together with them on model-based systems engineering. Besides university, I'm a member of the Lakeside Science and Technology Park, which is next to the university in Klagenfurt. And I'm quite active in the German Informatics Society. At the moment, I'm the spokesperson of the German modeling community and an elected member of the executive committee. So you can already see that I like to be engaged in different aspects which are not just related to technology and computer science, but also thinking about what we can do together with science and also with society. And if we talk about sustainability and digital twins, why should we talk about this? Now, a bit more than a year ago, somebody asked me a very good question, which was, what impact do you want to make with your research? And I think it's a good way to step back and think about what really fascinates you in research. And it could be a lot of things. It could be helping users, that we are providing usable software and great modeling tools. It could be to help specific user groups like elderly or disabled people. It could be to help software engineers that they have better software development processes. We could also provide ideas that we are making great startups, make them successful. We could support the governments that they improve their digitalization and hopefully reduce the bureaucracy. Might be also interesting for some of us. Or we could also support companies that they provide better products and processes and help them to get a little bit richer. Basically, there are different ways we can approach to make an impact. And I like this quote from Jane Goodall very much, because basically every one of us has to decide what difference we want to make. For me personally, I think it's the idea that we can give something back to society with the things that we do in our research in computer science is something interesting. But if we talk about society and the world we are living in, how does this world look at the moment? What are the challenges our world is facing? And I've brought you just some ideas. We have more than 700 million people which live in extreme poverty. We have water problems for a large part of this world's population. We have a lot of people who breathe polluted air in the areas where they are living. CO2 emissions have increased massively within the last years. We have a lot of young people which are not in education, employment, or training. And we also have a lot of problems when it comes to the minimum proficiency of reading and mathematical skills which are needed to live your daily life. Some of these aspects might sound very far away from us because it might not affect our personal lives. But if we think about a little bit nearer aspects, we are also facing these challenges. These are pictures just from this summer where we had quite high floods. They're 1 kilometer away from the place I live in Austria. And such extreme weather situations now appear more and more, which means we really need to take actions and think about what could we do and what could be our support in helping with such challenges. Now, I hope that all of you agree that it's not a best way that we continue on creating the world in the way that it is at the moment. But the problem is not so easy to find. It is not so easy to find solutions to the challenges that I mentioned, because the world is a very complex ecosystem. And the things that we do on one side might also affect other places and other areas where we don't really expect them to happen. So the question is, from us, for the EDT community, what are the things that we could do to contribute, at least a little bit, to a better world? And especially, what is such a better world? If we ask politicians, they would talk in this case often about sustainability. And sustainability has three main aspects which are focused on at the moment. One of them is ecological sustainability. So here we are thinking about the natural environment and try to preserve and protect it. This still means that we have to meet present needs, but we have to also think about the availability of such resources in future. As a second part, we have also social sustainability, where we have to focus on the well-being of people, and aspects like equity, human rights, or decent work are important. And the third area is economic sustainability, because we also want to have economic activities, but these activities should be in a way conducted that we have a long-term economic well-being. That's quite challenging because we have to balance between different areas like economic growth, resource efficiency, but also financial stability. And if we talk about sustainability, then we're talking about the overlap of these different things. So what you can see here are figures often used in research for that. Either that you have some kind of Venn diagram and you say sustainability, it's only the area where the three different kinds of sustainability meet. Or the other representation says that economic sustainability is only possible if you're also reaching social sustainability and environmental sustainability. And in the last years, also some further approaches have appeared here. So these more complex considerations where you also have to think about other areas like technical sustainability. Here we're often talking about technical depths, scaling, so a lot of the software quality attributes we're thinking about. but also individual sustainability. So what about the well-being of individuals in an organization? And if we want to be sustainable in practice, we have to break it down into concrete actions and goals. From politics, they have decided on certain goals that we should reach all together on this world. They are called the UN Sustainable Development Goals, and it's 17 of them, which are then further refined into 169 targets measured by 231 indicators. And to give you one example, we have SDG 7, which is talking about affordable and clean energy. Below that are 5 concrete targets, and below that one concrete target where we want to double the global rate of improvement in energy efficiency, we would have 6 concrete indicators which you could measure them. Now, that's already a lot of targets we would have to fulfill, and a lot of KPIs and data we would need to identify these aspects. But because this is not already complex enough, we are also having interlinkages between SDGs. Those could be positive influences or negative influences. The positives are called synergies, the negatives are called trade-offs, and they are still under research. So what you can see here, for example, is the synergies, so the positive influences between SDG 13 and all of the other SDGs. And you can also break that down then into more better figures. You can also get that in the link which is provided here. You can have a look at these overviews. So for example, between climate action, we have 26 synergies and 9 trade-offs to affordable and clean energy. The informations that we have in here are basically taken from research. So one of the examples for such a synergy and trade-off is if we increase the diversity of clean energy resources, we would have a positive influence, which is to enhance the access of modern energy services. And we can also have a trade-off, so a negative influence, energy affordability may be affected. So if we have more clean energy sources, prices might be higher, which is something that we already see in practice. And these informations are taken from publications. So you can see here the information about what year and title and by which authors this information was published. Those interlinkages are still under research. So a lot of them are added at the moment and also within the next years. They might be also be restricted to a certain domain, to certain regions, or a certain scale where they're interested. So we can already see that's a quite complex aspect. And the problem that we have here with all of these aspects is that the technologies we are developing affect all of that. So we also have to think about the positive and negative effects of the technologies we're developing. And we are developing digital twins for such technologies. So for production systems, energy systems, transportation systems, or devices in healthcare. And we are already collecting a lot of data about these systems in the real world. Having this data sounds quite interesting for sustainability. Now, when I'm talking about different application areas, to give you an idea about the use cases we are working on within the last years, together with other institutes of RWTH Aachen University and other industry partners. For example, we had a look into hospital transportation systems, a lot of use cases from mechanical engineering, so how to engineer wind turbines, industrial robot arms, injection molding machines, but also biomanufacturing processes. We've been working with colleagues on electric mining vehicles, and several other colleagues which are considering digital twins for civil structures, where you also have to consider building information models, but also financial calculations, for example, which are interesting here. And all of that, we also have a teaching structure, which is a Fischer Technic Factory, where we can produce our own products. And these things help us to understand digital twin engineering a little bit better, and also to have different kinds of systems that we look into that. But it's not only cyber-physical systems which might be interesting here. We could also think about digital twins for pure software systems if they are very complex and large. We could think about digital twins for organizational systems where we have the humans who are working there, we have the processes which might be interesting. We could consider biological systems where we have to think about how do we get the data that we need, or rather more complex socio-technical systems where you have both the humans and the processes and their goals on one side, but also the technology on the other side. All of them are having different requirements and their challenges. And this is something we have to bring together in digital twin engineering. Now, just to give you a short reminder of when I'm talking about digital twins, what my understanding is from this. Basically, I understand a digital twin as a software system, an active software system. And this digital twin is taking data from the original system and is able to control or send condensed information to the system. It includes a set of models of the system and a set of digital shadows. Basically, these digital shadows are a part of the data and their aggregation and abstraction. And those are updated on a regular basis for certain purposes that we have in a digital twin. And we're able to have a set of services which use the models and the digital shadows to get specific information that we need of a digital twin. The digital twin is able to interact with the original system, so it can provide information about the system context, which is something the original system might not have before, and it is able to send it control commands. Now, what makes digital twins so interesting for us in research? Basically, it's this ability that digital twin enables us to connect the reality with the digital world and back. And this fascinates me personally a lot because I really like modeling and abstraction, and sometimes I don't understand why for some people models are not so important or that they don't understand why they can help us. And I understand it on one hand side. So if you use them only for documentation and then throw them away, or if they get outdated when your system evolves, they might not be helpful. But in this case, in digital twins, with this connection to reality, the connection to real data that we have, we are able to produce an added value. And this added value is something which is specifically interesting for sustainability aspects. So the following minutes, I will be considering two main questions. The first one is, how can we use digital twins that we are able to assess the sustainability of systems? Now, here, sustainability is especially interesting of the system that we are looking at. If we use digital twins for the sustainability assessment, then it's interesting that we consider different sustainability targets, so that we're able to monitor, calculate, and visualize such key sustainability indicators, but also that we actively do something with these indicators, like use them for simulation or forecasting. If we think about using, for example, such digital twin services in a production domain, it's interesting that we have the ability that we simulate already different variants before building a physical object, for example. This is not completely new to digital twin engineering or the use of digital twins, but we can use it on a specific focus, like to improve resource efficiency, like an aspect which is interesting for sustainability. We could also facilitate the optimizing of production processes towards waste reduction, energy saving, aspects which are interesting for sustainability. We could also think about adaptability possibilities that we can use to change the cyber-physical system to improve resource efficiency. And especially in the production domain, we're also creating products, maybe more complex products. We could also already think about responsible consumption and use of the products that we are creating and could already deliver that within the systems. Now, the actual systems we're looking at could be of any kind of system. And to make it a little bit clearer, let's have a look into two specific ones. The first one we're starting with are pure cyber-physical, pure software systems. So if we think about pure software systems, we can have digital twins which accompany the whole life cycle of the software system. In the design phase, we can think about services which enable the analysis of sustainability. We could already use architectural models that we have created in this phase and try to optimize consumed resources. We could also do scenario-based analysis where we try to identify which resource usage would be better in which variants that we have in the plan, in the design phase of the software system. If we think about the second larger phase, the implementation or generation, here we already get a lot of data from logs of our execution sequences. We have also data about research usage. We have source code metrics that we have in this phase which occur, and we can create digital shadows of that which can be used in services. In services, for example, where we can identify and optimize resource intensive code sections, or we could also analyze the development process itself. So think about what are least sustainable parts of this process where we might have bottlenecks and other aspects. When it comes to the operation phase, that's the phase where most of the data is coming from the system. Here we have the runtime data of the software system itself, where we create the digital shadows from. And the services that we could have here is basically clearly monitoring, reporting services, like for every digital twin, but we could also think about analyzing sustainable operational energy peaks of our software system. We could think about optimizing and intervening in the software system, like allocating the resources based on the current needs, or also reconfiguring system parameters. And to give you some ideas also about the end of life phase, here it is interesting that we are able to draw conclusions about the relevance of certain components, and also, for example, their reliability if we want to use them in future software systems. So we could have a look into how was the planned behavior of a software component in the design phase and the actual behavior it had then during operation. We can compare the energy consumption which it had in reality. We could also have a look into the test reports and see if there were integration problems, that maybe this component is something which we should not reuse in a future system. Those are just some of the ideas how a digital twin for a software system could be used to improve the sustainability of such a system. More aspects you could find in the Greens paper that we had at the Greens workshop this year. But there is still a lot of questions open in this area. Questions like, how are we able to model sustainability metrics? What services would be really helpful for developers when they are developing or maintaining such software systems? And also a very big question is, at what size of a software system would it be helpful that we have an additional digital twin which would accompany this software system? Now, when we come from software systems again back to cyber-physical systems, how can we create digital twins for such sustainable cyber-physical systems? An example I brought to you here is a citizen energy community, and we want to have a look into the planning phase of such a system. So a citizen energy community is a community where you have citizens and small commercial entities like residential hubs, commercial hubs. They work together with local energy generation and storage. So you have facilities for that. They do their local energy trading, and the citizens interact directly with the electrical distribution system. Now, if we are in the planning phase of such system, the question is, how can we enable system developers of such systems that they are able to evolve a system, but in a sustainable way? Therefore, what we need to do is to assess the sustainability of such systems in some kind of experimentation kit. What we did here in the first step is we have tried to model such systems. Here we've done it with an architecture description language, MontyArch, which is a part of the Monty Core language workbench. Here you can see a component basically having the different parts in this system as own components, like for the hospital, commercial hub, and other parts, and ports, which are the connections basically between these different kinds of components. If we are interested in sustainability, we might add some language components as an addition to this language, which helps us to define which sustainability goals we want to achieve. In the example provided here, we want to reach goal 7, which is affordable and clean energy, goal 11, sustainable cities and communities, and goal 13, climate action. Now, what we would need in addition is more information about each of these components that we have here. Therefore, we also need architecture diagrams for each of the components. For example, for the coal power plant, you can see an example here. We have again added an own SDG language component where we have domain-specific indicators for energy planning. So in lines 7 to 10, you can find some of these indicators. For example, what is the consumption of this power plant? How large is the CO2 emission? How large is the landscape usage, and other indicators which are relevant for here. Using this information, we can do an assessment, and this assessment, for example, had a result that we have an alarming level of CO2 emissions with a negative impact on SDG 13, minor benefits for SDG 7, and no positive influence on SDG 11. So we have not really reached the goals that we want to do, which means we want to get a little bit better. If you're interested in the language engineering part of this, I can suggest you to have a look into that paper that we had at the SLE conference this year, where we are talking about different language composition approaches. So how is it possible to get such language components within already existing languages? Then please have a look into that paper or ask me later on. Now let's come back to our evolvement of the system. So in a first scenario, in this evolution, we are looking into changing a component. So what we want to do is we want to replace the coal power plant with a hydropower plant. Therefore, we are creating a new component model, which is again describing the hydropower plant with the important aspects, which is in our case the sustainability indicators, again with the consumption, CO2 emission, landscape usage, and other information that we have about this component. And we are starting the assessment again. Now the result of the assessment now shows that we have reduced the power plant's CO2 emissions by over 95%. We have more landscape usage, but we have altogether slightly positive effects of SDGs 7, 11, and 13. So basically we have reached the goals that we wanted to reach. Sounds like a very easy approach if we could do it that easily in practice, but especially the step of the sustainability assessment is quite challenging in research. So either we have to assess that by experts, or we can pass it on to assessment systems, but a lot of the systems are either very domain specific or exist on a conceptual level. You could have a look into this very nice publication of some colleagues from the models community, where they were talking about sustainability evaluation experience R, so an experimental toolkit where we have a connection between doing what-if scenarios together with self-adaptive systems which are connected to that. So for more ideas on how to embed such sustainability description in ADL models, please have a look in the paper. And as I already said, we are working on this aspect not only from computer science, but especially together with a lot of other colleagues in this area. Here you can see some of them. They are from the EON Research Center, HumeTech, innovation management, but also decision analysis and socioeconomic assessment. And especially this assessment is an aspect that we were talking about a lot, and where we from computer science also need to come up with more solutions. Because if you look into the sustainability assessment, at the moment, it includes especially life cycle sustainability assessment as an approach with 3 different sub-areas: environmental life cycle assessment, life cycle costing, and social life cycle assessment. So here you would see these 3 different kinds of sustainability that I had on one of the first slides. But basically there is a problem because these LCSA indicators which exist and the SDG goals, there is not really a connection between a lot of them. So the last number said that 14 of the SDG goals have not been assigned to an LCSA indicator. And there are also a lot of other challenges because at the moment there exists some tool support to do that assessment, but there's also a lot of manual effort. You really need the data. This is something, if you think about our use cases for digital twin engineering, where our approaches could already help for some aspects, not for all of them, but at least here we are getting more data. Then we have the problem that in practice, some of the approaches only consider 2 of the 3 sustainability aspects, which means it's not really full sustainability. The areas are not really connected. It's not clear what the system boundaries are. So what's the scope on where you have to look into, is my system still sustainable or not? You could also weight the results in different ways. So in the example that I had before, we have now more landscape usage. If we use a hydropower plant, what is more important, the landscape usage or that we are creating less CO2? So this is something also a question of weighting the results a lot. And there is still lack of agreement in the international community on aspects like the social targets, which we should achieve to also reach some of the social indicators. And especially technical and individual sustainabilities are also not really included in such aspects. Therefore, at the moment at RWTH Aachen, there is an interdisciplinary research group starting, which is consisting of colleagues from mechanical engineering, energy engineering, informatics, chemistry, geography, business administration, and also social science, which is starting to think about more holistic approaches towards sustainability assessment, where we are thinking about the assessment of technologies, products, but also policies on different levels of analysis. And the idea is also to create here an open science approach, so that people from the whole world are invited to also be a part of this development. And if you want to find out more about it, please go to this website, and we're happy to contribute together in solving some of the questions and problems that we have in this world. Now, let's get to the second question, which might also be interesting for us when we're thinking about engineering of digital twins. So how could we do a sustainable engineering of them? Now, if you use the search machine of your choice and look into sustainability and software engineering, you might find a lot of articles talking about green software development, sustainable software. And when we're talking about green, we are mostly talking about ecological sustainability. So we're talking about green energy, hardware, green software engineering processes, or different aspects which are interesting. And sometimes they appear to be a little bit like greenwashing. So it's like, yeah, some of the people who were talking about corporate social responsibility, but were only paying minimum wages and hinder the formation of unions. But that's just one aspect of it. A lot of companies and people treat it very serious. And I think this is also what we have to do in research, basically. The term green IT is mostly related to ecological sustainability. So here we have the aim to reduce environmental impacts of the IT systems that we are creating. We're talking about energy efficient hardware, data centers, servers, and monitoring systems. And especially it is interesting because the biggest impact of ICT as an industry is the amount of greenhouse gas emissions. I was wondering how much it was, and when I did my research for the talk, I found out it's between 1.5 to 4% of the global greenhouse gas emissions, which is quite large. And these numbers are still growing because some of the newer technologies we have invented within the last 1 or 2 years are producing even more greenhouse gas emissions. So how could we improve that with the research that we do? One of the approaches comes, for example, from the Green Software Foundation, where they are talking about green software development, that we should focus on features with higher power consumption or common usage scenarios and think about reducing that. We should also think about the data that we use and try to reduce it. We should think about limiting computational accuracy where it is not so important. We can monitor the real-time energy consumption of application. We could use less power-consuming machine learning models. And we can also monitor the real-time power consumption during the development. And some of these aspects remind us already a lot about digital twins. So digital twins with the monitoring functionalities that they provide, that we are able to simulate usage scenarios, that we are working on computational accuracy with fitting models that we're using, and that we are able to reduce data usage by defining digital shadows, which only use the data which we really use for the purposes that we have with our digital twins. Now, these aspects have a quite strong focus on ecological sustainability. But how can we balance these requirements with business goals, for example, or customer wishes? Because some of the problems are that, what was the saying? The greenest software is the one which is just not existing because it is not creating any greenhouse gas emissions. But that's not really what we want to have within our life. Now, what other approaches exist to relate sustainability in software? Another term we can find is sustainable software engineering. Here, this is, for example, a guideline from Microsoft for software engineers that they should think about carbon, electricity, hardware, and hardware efficiency when they're building their applications. They should be carbon aware so that they use electricity with the lowest carbon intensity, that they should measure to improve the sustainability, and also define concrete mechanisms for carbon reduction. Again, very strong focusing about environmental sustainability. In research, we can also find other aspects like human sustainability in software engineering, where we have to think about the impact of outsourcing or impact sourcing, which is called there, about ethical outsourcing, about fair trade software. So all of that, where we're thinking about training and hiring marginalized people, for example, are aspects that could also deliver to other areas of sustainability, which are important, that we consider them all together. And another very interesting approach is provided by Birgit Penzenstadler, who tries to define sustainability as a concept with 3 different variables, which is system, function, and time. So here we have preserving the function of a system over a defined time span. And if we think about software systems, then we could place different information into these 3 variables. So if we have the development process as a perspective, then it is interesting that we think about the responsible use of ecological, human, financial resources. If we have software maintenance as an aspect, which is interesting for us, Then we have to think about maintaining and evolving a software with a minimal environmental impact, a well-managed knowledge and sufficient economic balance. So again, these different kinds of sustainability are interesting. If we think about the system production, then we also need to think about the hardware and the resources that we need to produce it. And if we have the system usage, we have the longest period of time, which is interesting. So here we have to think about the whole use of the software and its operational environment. And all of these perspectives should always relate to an absolute definition of sustainability, where we have as a time span various generations, where we have the function, which is the satisfaction of needs, and the system is the whole humanity and its ecosystem. And we also have to define this in relation to this larger idea about having a sustainable world. Now, how does these aspects relate to digital twins? If we come back to the understanding of digital twin, we have them as active software systems, which means the systems can be sustainably developed. We can apply the practices as we also apply it for other software systems. Now, here it's now interesting for us, what are the specifics if we talk about digital twins, and how could we support that with model-driven engineering especially, and also what are challenges if we're thinking about MDE use for sustainable digital twin engineering. The ones of you who are familiar with model-driven engineering might not be very surprised if we talk about the general benefits of applying model-driven engineering. Aspects like increased development speed and reduced development time, but also better software quality, improved maintainability, or also empowering domain experts are aspects which can be found in literature. Most of them are supporting economic sustainability. But if we have a further look into the details of digital twins, which is basically also the parts that we have in a digital twin, we can find out a little bit more. So if we think about the models, in addition to the models that we have for digital twin engineering, we would also need to model sustainability aspects and consider these models as part of our digital twin. Like models having sustainability requirements, sustainability goals, and then also having this both for the engineering processes, but also for the runtime of the digital twin. Then we need data to find out the sustainability targets and KPIs that we have, how that we measure them, and also think about aspects like reduced data usage. When it comes to the services, here it's interesting to monitor indicators that we can simulate and forecast them, that we analyze the digital twin and suggest, for example, more sustainable processes, less power-consuming services that we use, but also aspects like visualization of the metrics and analysis results might be interesting. Now, applying model-driven engineering for digital twin engineering also comes with some costs and aspects we should consider within our research. Firstly, we have to understand the cost of automation, which means we have to balance a high quality in engineering process, but also we should think about not wasting resources. We therefore could analyze our own processes. So are the nightly builds really needed? Is the amount of tests that we run or daily deployments really needed? Aspects like iterative builds or other points is something which we could improve here. But clearly, we still have to think about how can we still get a high quality in the software engineering processes in the products that we're creating. If we are using power-consuming services and models within digital twins, we have to analyze these services and think about how could we use, for example, less power-consuming machine learning models or pre-trained models that we avoid the retraining of networks. When we're thinking about twinning functionality of a digital twin, here we have to consider which degree of synchronization is really needed, because it might mean a lot of communication that is required. And also what accuracy of models is needed, especially for simulation models. This is some aspect which is also highly of interest for sustainability aspects. And when it comes to the composition of federation of digital twins, how can we compose them to improve maintainability, or what are the costs that come along with federation or integration? And you can already see that there are a lot of balances and trade-offs we have to find in different goals that we want to realize. Now, what is also missing here are a lot of aspects regarding social sustainability, for example. So this is something where we need more research also to be done within future. And when it comes to also thinking about the connection between digital twin in the design phase and the digital twin in the operation phase, it would also be interesting to have this continuous DevOps cycles and also think about sustainability in these continuous DevOps cycles. Within the MBDO project, the model-based DevOps project, which is done in cooperation with colleagues from Rennes and EDT Stuttgart, we are thinking about how to improve sustainable production by using model-based DevOps use cases within a production domain. And especially aspects which are interesting here is if we have already some sustainability models in the development processes, how are they then interesting to get them together with the data that we create during monitoring of the cyber-physical system in operation, and how do we get this information and also back into improving the models and the information that we would have. Now, to come to an end, I hope I have shown you some aspects which might be interesting to do in future, that you might also want to make a difference with the research and the work that you're doing. From the sustainability perspective, it's especially interesting that we either use digital twins, that we are assessing the sustainability of different kinds of systems, but also think about sustainable engineering methods that we create the systems, sustainable methods to run digital twins, and especially also that we're thinking about how can we model sustainability, and not only one perspective, but also these different kinds of perspectives that are interesting for us. So thank you very much, and I'm happy to answer your questions.
Thank you very much, Judith, for this very inspiring talk. Give me a second to stop the recording.